Hello and welcome back. This is chapter 2 communication, and today this is the video. This is part 2. All right, so we have already covered part 1 and now we are moving to part 2, and in this part 2 we are going to cover these topics, these subtopics: data transmission, Ethernet, CSMACD, hardware item needed to from our LAN and WAN, wired networks, wireless networks, and star topologies, all the topology, bus, star, mesh, and hybrid. Okay, so let's begin. Okay, so we have here data transmission. Data can be sent through a medium. Data can be sent through a medium. It can either be a Wi-Fi or Ethernet, which means a cable, in different modes. Simplex means data flow in one way. Half duplex means data can move in either way. Okay, and full duplex means that it can go simultaneous in both ways. Then we have then we need to understand that what is Ethernet is a series of it's a cable. Okay, series of computers connected to a single common Ethernet cable. Okay, for transmitting data, it writes the data as an electrical signal on the cable using MAC address to make things easier to send it at only to that personal computer. CSMACD, it's a protocol used in Ethernet cables in order to prevent collision detection. Like in bus topologies, there could be a chance of collision if more than two. Any two random computer is sending the signal at the same time. So definitely it would be a huge chance for collision. So in order to prevent that, we use this protocol CSMACD. Carrier sense multiple access with collision detection. It's used for early Ethernet networks, but now it is no longer used. But still, we need to understand why it was used in those times. Okay, so it's a protocol to prevent collision. First of all, it checks whether if the sender is ready to for transmitting data packets. Check if the transmission link is idle. If it is not busy, transmit the data and check for collision. If collision happens, transmission happens. If collision happens, then it waits for random time interval. If collision happens, then it waits for a random time interval. After some random time, it again attempts to transfer the data. The random time must be different for each computer so that collision does not happen again. Then we have these three categories on sending the data. There's three types of categories in sending the data. Okay, so first here is broadcast. Broadcast means that, for example, if we have multiple computers and we have a hub as a router, if we have a hub to manipulate the data, and let's say that computer want to send the data to computer B. So the data goes through a hub, and then hub tries to broadcast all the data to all the computers. It doesn't know which computer to send to. So this is what it means. It means one-to-all communication, broadcasting the data to all the computers. Okay, one-to-all communication. Multicast means which means try to send the data to that specific user, which means it knows that, let's say that computer A want to transfer the data to computer B. So that data will go to a switch. Switch is a much smarter, it's much smarter than hub. So switch will try to know that if computer A wants to transfer this data to computer B. Okay, so yeah, this is the MAC address and computer B is here. Then it tries to transmit that data. Okay, if we are having if for example computer A want to transmit to three specific users, three specific computers like BCD, then switch will do the job for you. Okay, so transmit information to specific users. Then what we have here is unicast, which means one-to-one communication. Okay, only computer A to computer B, computer B to computer A. This is unicast, one-to-one communications. Then what we have here is hardware item need to form a LAN and a WAN. We are focusing on the hardware. What are the hardware required to make a LAN or WAN? So one of them is hub. Hub is hub is like a router which acts as try to manipulate the data, try to transfer the data Like if computer A sends the data to computer B, that data will first go through a hub or a switch or router, one either one from the three options. Okay, so for example, if it is a hub, then it will do broadcast. It doesn't know um, it doesn't know which computer to send to, so it try to broadcast to all computers, that try to send the data to all the computers. Okay, so it's very cheap and simple but wastes bandwidth. It broadcasts messages. Each incoming bit is replicated in all other interface. See, there's a security problem definitely, because there's no privacy. There's a privacy issue, and it is used to form a LAN network. Okay, then what we have here is a switch. It is much smarter than hub. So it tries to check the data packets received. Like for example, if computer is sending the data, that data will be checked by a switch. It will see the data packet received and work out its destination address. Then it will see that what is the destination address of that particular data. So it send the data to an appropriate computer. So you can say that switch is much smarter than hub. It knows where the data is coming from, and it knows where to send it. Then secure and efficient way of distributing data. It is very secure and efficient. Definitely, it doesn't waste bandwidth, and it is very secure as well. There's no privacy issue here. Each computer has a MAC address and identifies it uniquely. Then what we have here is a router. Router is much more smarter than switch and hub. It enables data packet to be routed between the different networks. It makes the whole WAN. Routers are the only thing that we needed to make a whole internet, because whenever the data are being are traveling, they are traveling in router to router to meet that particular destination. So data packet to be routed between the different networks, for example, to join a LAN to a WAN. Can move data between networks. That's what I'm talking about. Can move data between networks. Can calculate the best route to a network in destination address. Work as a default gateway. We'll see what is gateway. Okay, so it act as a default gateway. We'll see what is gateway. Restrict broadcast to a LAN. Yes, definitely it doesn't broadcast. It always try to work very smart way, that where the data is coming from and where to send this data. Okay, it doesn't broadcast to a LAN. Can perform protocol translation, allowing a wired network to communicate to a wireless network. Okay, wired network to wireless network. It makes a protocol translation, and that's a bonus. It can assign private IP address to each individual device on the network. Like for example, if there are 3 or 4 computers or 3 or 4 mobile phones, iPad, etc., all these devices are connected to a router, then router will try to assign private address to these individual devices on the network in order to manage the traffic of data. Try to make a receive and sending to each one of these devices individually, which could make it much more smoother. Okay, so this is the router, and assigning the IP address to each individuals, assigning IP address, and then that router since router is giving since the data is in digital, we need to convert this digital to analog signal, because the internet works in analog. So in order to do that, we need a modem tries to try to convert the digital to analog signal. Okay, it tries to convert the digital to analog signal, and that's how you try to access the internet. And for example, if you are sending the data, that data is converted to analog signal, and then analog signal is going to the internet. And whenever we try to receive something, it goes through a modem, convert to analog to digital, and digital to any particular device, okay, connected to the router. VLAN. What is VLAN? VLAN is Wi-Fi router. Try to connect to VLAN. What is VLAN? Provide wireless network communication over fairly short distance, up to 100. Connect it. Instead of doing it with a wire, we can connect to a router wirelessly using a VLAN. Gateway converts okay, so what is a gateway? A convert data packet from one protocol to another. A node that acts as an entrance to another network, used to connect two or more LANs using different protocols. Okay, different protocols. All right, repeaters. Gateways. Let me see what is gateway for. Gateway convert data packet from one protocol to another, which means having different protocols. We try to make a communication between different protocols. Act as an interest to another network, connect two or more LAN using different protocols. Okay, the gateway is all about managing different protocols. Okay, and try to send the data and receive the data between two different protocols. Like for example, if there are two or more LANs and they are having different protocols, like one is using a Wi-Fi and the other is using Ethernet cables, then in order to communicate, in order for for those LANs to communicate to one another, we use a gateway. Okay, it's written here, used to connect two or more LANs using different protocols. Repeaters. When signals are sent over long distance, they suffer attenuation, which means their signal, you can call it signal loss. Repeaters are devices which are added to transmission system to boost the signal as it travels. As it can travel greater distance. It boosts the signal. This is what repeater is for. Bridge. What is a bridge? Connect one LAN to another LAN that use the same protocol. This is the difference between a bridge and a gateway. In gateway, when there are two or more LANs and they are having different protocols and they wanted to try to communicate to one another, then we use a gateway. But if, for example, if two or more LANs are having the same protocol, we use the bridge. Okay, often used to connect two different parts of a LAN so that they can function as a single LAN. Okay. Connect two different parts of a LAN. Modem. To allow the transmission of digital data over analog communication channel, we need to use a modem. Does the inverse and convert data received over the analog network into digital data, which can be understood by the computer. Hardware computer that allows a computer or another device such as a router, switch to connect to the internet. Okay. Modem is what brings the internet into your homes and businesses. So that's what I was talking about. Digital to analog, analog to digital, and this is a modem. Yeah. Okay. A network protocol. An established set of rules that determine how data is transmitted between different devices in the same network. WAP, wireless access point. It's connected to the wired network at fixed locations, receive and transmit data between the VLAN and the wired network structure. Okay, it's used, add Wi-Fi capability to an existing wired network. This is what it's all about. Adds a Wi-Fi capability into an existing wired network. Okay, NIC, network interface card. The LAN port on an end system is connected to a NIC. By default, each NIC has its own unique IP address. Hardware components found in devices such as mobile phone, computers, which help to connect to a network. So it's all about connected to a network. WNIC provide interface to wireless network as an antenna. Receive analog radio waves and convert them to digital binary. Checks incoming transmission for convert MAC IP address and ignores transmission not intended for. Checks incoming transmission for correct MAC IP address. Take digital binary input and convert to analog waves. Take digital binary input and convert to analog waves, send a radio wave via the antenna. It's all about it's all about providing the interface to a wireless network as an antenna. Providing the interface to a wireless network as an antenna. Okay, it's all about doing this in wave and try to connect to another in this way. Okay, so this is wireless access point, which we have discussed. Adds the Wi-Fi capability. This is wireless access point, and we are giving a Wi-Fi. Like whenever we try to we have a mobile phone and we use the hotspot and we are connected two or more devices to that. This is what AWAP is. Then it's connected to a router, and router is connected to modem, and this is how the whole network will broadcast a Wi-Fi signal. Okay, now we have wired network. So twisted pair cable, most common cable type used in LANs, lowest data transfer rate and suffer the most from external interface. Very cheap. Fiber optic, it is very fast, most commonly used to send data over longer distance, offer the best data transfer rate, the smallest signal attenuation, and have a very high resistance to external interface, high cost, use pulses of light rather than pulse of electricity to transmit the data, using a pulses of light. Coaxial cable, most commonly used cable in MEMS and by cable television companies. Cost is higher, offer a better data transmitter rate and are affected less by external interface, suffer from the greatest signal attenuation. Okay, the small way. Okay. Coaxial cable have a suffer from a greatest signal attenuation, and in twisted pair it's doesn't have much. Fiber optic is the best in one of these. You know, it's fast. It goes in long distance. Even though it's high cost, but it travels in at the speed of light, and signal attenuation is very low and have a very high resistance to external interference. External interference like raining and all that. So now attenuation means refer to any reduction in the strength of a signal. Natural consequences of signal transmission over long distance. This is what attenuation really means. Then what we have here is radio waves. Radio wave and microwaves. Radio waves are primarily means of carrying data over a wireless network, transmitting information between devices and a router through frequencies used for WAN and mobile cellular phones. Since it can penetrate thinner walls, plants. It can penetrate thinner wall plant furniture. These waves are omnidirectional in nature, which means they can travel in all direction. Okay, omnidirection allows Wi-Fi connectivity in networks. And what are microwave? Microwaves used in point-to-point communication system on the surface of the earth in satellite communication. They are unidirectional in nature, which means that they can travel only in straight line. Usually one-to-one communication, allows Wi-Fi connectivity. Okay, and these radio waves and microwaves can be used in a for if a radio tower if radio tower A want to send the signal to radio tower B, it will send the microwave signal and then it will reflect back and came here. So these are the microwave and microwave signals, and you can say, or it could be radio waves. Microwave and radio waves are used in here. Okay, so radio waves are used in mobile cellular phones, and microwaves are used in satellites, point to point communications. Okay, what is infrared? Infrawaves is used in wireless technology for digital data transfer, used for short range communication. Computers can transfer files and other digital data bidirectional, can transfer files. Most common applications are remote controls that are used for TV, DVD players and stereo system. Alright, so these were the wireless networks and these were the wired networks, and now we are coming to topologies. So let's start with bus topology. The bus topology is using a single central node to which all computers using a single central cable to which all computers and devices are connected. Data travel in one direction only. Terminators are needed. The terminator are needed to each end to prevent signal reflection bouncing. A message must be broadcast even though it might be intended for one system. That's a disadvantage, but we're going to cover this, don't worry. Each node looks at each packet and determine whether or not the address of the display in the package match the node address. Each node, which means each computer. It's talking about the computer. So each computer looks at each packet and determine whether or not The address of the recipient in the package matches the node address. So each packet have a node address, and it will try to see whether it's for me or not. Like if you're having an invitation from a stranger, you will see that whether this address is mine or it's someone else, right? So what are the advantage? If one node fails, the remainder of the network continues to function. Okay, so if one computer is shut down, the other computer will continue to function. They are not dependent to one another. Okay, so they are all independent, and they are all function. They all are running independently, right? It is easy to increase the size of the network by adding more nodes, more computers. That's the advantage. And what are the disadvantage? If the main cable fails, the whole network goes down. The network is not secure since each packet passes through every node. What I'm saying is broadcasting. That's the biggest disadvantage. It is very efficient for small networks and does not rely on very high data transfer speed. Okay. Now we are coming to star topology. This is star topology, right? There are devices connected to one another on a hub or a switch, either way, or router. But router is much more better than hub. Use a central router, hub, or switch, and each computer is connected to data going host to host is directed through a central router, hub, or switch. If the central router, hub, or switch fails, then the whole network goes down. So it's the hub is the heart, and these devices are more like head, legs, and hands. Hub is the heart. I mean, the central node is the heart of this topology. It's the center. It's very important. If it goes down, the whole topology, it's the whole system is going down, crash. If one of the connection is broken, it only affects one of the nodes. Again, it's independent. The computers, the device are independent to one another. If one device fails, the other will continue to function. Whether what will happen to other? No. Transmission is duplex. Okay, and messages from the central device might be unicast, multicast, or broadcast depending on the central node, whether it is a hub, switch, or if it is a hub, then it will broadcast. But if it is a switch or router, then it will multicast or unicast depending on the data coming from, like for example, depending on the request. Computer is sending the data to computer B, it is unicast. Computer is sending the data to multiple computers at the same time, it is multicast. Okay, any type of network cable can be used for the connection, wired or wireless. The advantage is data collision are greatly reduced due to the topology. If one of the connection is broken, it only affects one of the nodes. What are the disadvantages? Initial installation costs are very high. If the central fails, the whole network goes down. Mesh topology, this is a mesh. It's more like a web, complete web. Each computer is connected to another computer. Each computer is connected to all other computers. Each computer is connected to all other computers. Each and every computer. Mesh topology enable many devices to share internet connectivity. Connection of telephone, regional office, okay, home automation, smart, central and smart. Okay. Smart building. Okay, so you can understand here that it's this type of topology is used when many devices try to share the internet connectivity. And when there is a telephone regional office, this is where this topology is definitely being used. This way it's very helpful. And in home automation, smart HVAC control, and smart building. The internet and WAN MAN are typical use of mesh topology. So okay, so it's the internet is the example of a mesh topology. Many examples include industrial monitoring central, where sensors are set up in mesh design and feedback to a control system which is part of the system. Advantage, easy to identify where faults on the network have been occurs. Okay, so if there's a problem, then we can easily identify it thanks to this topology. Any broken links in the network does not affect the other nodes. Good privacy and security. Since packets travel along dedicated routes. Okay, having a different route, having different roads to like for example, if there's a city city A is going to city B, but there are so many roads, so it's very secure and very having a privacy as well. So it's good having a along going through dedicated routes. What are the disadvantage? A large amount of cabling is needed. We need a lot of cabling, which is expensive and time consuming. Setup and maintain is difficult and complex. Maintaining it and setting up is very difficult as well. So these are the disadvantage. Otherwise it's a very unique and very interesting, helpful and amazing topology, this mesh topologies. Hybrid topology is another level. It's more like a mixture of two or more different topologies. Like for example, you are having a bus topology, star topologies and ring topology all connected to one another. This forms a hybrid topology. So it's being used in banking, in education institution, automated industries. Mixture of two or more different topologies. Handling of packet in hybrid network will depend on which handling of packets in hybrid network will depend on which of the topologies are used to make the hybrid structure. What are the advantage? They can handle large volume of traffic. It is easy to identify where network fault has occurred, like in mesh topology. They are very well suited to the creation of a larger network. Disadvantage, they can be very complex to install, configure and maintain. So this is the example of hybrid topology. This is star topology, ring and bus topology. And thank you so much. This is the end of part 2, and in the next video we're going to understand, we're going to see all of this is part 3, and I hope I'll see you guys in the next video. Thank you so much.